Hi, good morning, my dear student. Yes, last class we have discussed very important concept of the coset, right coset, left coset. A is congruent of B, decompositions of coset. So in this expression, we have found out for the so many theorems. In this expression, already you know that one of the greatest Lagrange's theorem is also expressed. So order of h divided by order of z. So this expression we have proved that. By the way, another one of the greatest corollary we are going to discuss in front of you. In this corollary, what we going to say that, what we are going to discuss in front of you. Already you know that one of the greatest geometry part Euclid their explanation. In the supremum ai dot aj, law of exponent says that a to the power I plus j. So we are, let us consider I plus j is consider mq plus r 0 less than, it means we are going to take a value 0 less than r less than m is there. So particularly we are going to express for the one of the greatest real number part. That part we are going to exist for equations. That corollary says that how it values we are going to prove here. So let us discuss first one by one how they are going to take step to steps are there. Let us by here. A consequence of Lagrange's theorem. One of the greatest consequence of Lagrange. In this one, the order of every element of a finite group is divisor of the order of group. So keep in your mind, every element is a finite set is there. In this finite set, divisor of order is finite. So in this expression, we are going to take, let g be a finite, some countable numbers. Already you know that there are, it means finite means it is one of the countables, counting the numbers, limitations that exist. So then only for a belongs to z, order of a, order of element, order of a can we are going to take. So order of a is equal to m. So order of m is equal to e. Definitions of order of element. So this one we are going to prove here for all, because let g be a finite set and a some element, one particularly one element we are going to take, then exists for the order of a. So order of a is equal to m is there here. So in this order of a we are going to prove that it is a Lagrange's theorem, then only we can call consequences. So order of a divided by order of z. Here actually we in that expression order of h divided by order of z, right? So order of h divided by order of z, it is a Lagrange's theorem. In this Lagrange's theorem, order of h is a subgroup, but expression of the element a is there one a finite set. So order of a is equal to m. This expression already proved that. Then consider subset. What is the subset? H is a subset. So what those are element? A square, a cube, so on, a to the power m is equal to e. Already we got it. H is a square, a cube, a4, so on, a to the power m is equal to e. This condition, H is a finite. The ai and aj, some elements are there in the subgroup. The conditions are very important. ai to the power dot aj, those bases are same, adding the power amq plus r. So this expression Euclid theorem. So we are going to know that Euclid's postulate or theorem. So this statement I plus j mq plus r, it means remainder theorem or otherwise divisor, right? Some theorems are there in that expression. So this one, I hope ai, aj, this replace I am going to consider and split up the value a m cube a dot. So a m only I can consider to the power. This means it is one of the greatest identity. So a, it means e, ar, aij, ar belongs to h. Hence it is a closed subset is closed because finite set is there. Every closed and subset is there. It is called bounded. We are going to express. Hence h is a subgroup. When it is a closed, it means some part it can consider one portion that is called closures. So further all the elements H are different. Every elements are in the subgroup of all the elements are different. So order of H is equal to m. there are m element. By Lagrange's theorem, already you know that order of h, this one m divided by oh, m, this means order of a, because here I am going to consider. Hence we prove that consequency of Lagrange's theorem is a finite set and finite elements are there. So these are very important. Next class I am going to defining another corollary is there. Thank you so much. I will continue the next Lagrange's theorem. Thank you. Bye.